Okay, I asked you to take a look at this worksheet, so let's see what you're thinking here. As far as identifying the 4 lines, the ECG tracing, I'm going to do that in green highlighter, you probably recognize. Up at the top, that's the QRS complex. T-wave. So that one's pretty easy. Let's take a look at the other 3 lines. Those are a little bit harder. Now what I'm noticing is that the pressure is low here and that the pressure is higher here. And so I see that whatever this structure is maintaining a higher pressure over time than these other 2 lines. And so when I look at my options, it's either a blood vessel, the aorta, the atria, or the ventricles, so chambers of the heart. So because the blood vessels, like the aorta, have a smaller diameter, they're going to have a higher pressure. And so I'm thinking that this is a blood vessel. So the aortic pressure is represented by this line. And so that leaves me to decide between the which one is the atria and which one is the ventricles. So there is a big difference between these 2 lines, because the one with the squares, I notice that pressure, it's lower and it stays pretty flat. Compared to the line that's made up with the circles, I see that pressure is low, but then I see that pressure goes really, really high. And so I'm thinking that the ventricle, the bigger, more muscular chamber, is probably the chamber that can really increase in pressure, actually increase to the point of the blood vessel, and then decrease. And so I'm going to label that circle line the ventricular pressure. I think the ventricular pressure is going to be low to a point. And then it's going to increase, and then it's going to decrease, and it's going to stay lower. Compared to the atria, because those are smaller chambers, I'm thinking that pressure is going to, stay more steady and stay on the lower side. And so as far as identifying what lines are what, that will do it. So let's take a look at some other features. I asked you to identify the parts of the Ecg wave, and so we know that the P wave is atrial depolarization. I see it cut off over here. This is the QRS complex, and then the T wave, ventricular depolarization. And so that's another hint, actually, because we know the QRS complex is ventricular depolarization. And I know that ventricular depolarization is the signal for ventricular contraction, meaning that this electrical change occurs just prior to ventricular contraction. And so when I look at the graph, I think again that we're right, that when the heart has a depolarization through the ventricles, look what happens. Ventricular pressure increases. It increases until it meets the pressure of the blood vessel. It stays high, and then the ventricular pressure starts to go down, which makes sense. That's corresponding with the T-wave, ventricular repolarization. So it looks like this point in time, that looks like ventricular systole, right? Looks like the ventricles are contracting. And so let's take a closer look at this. It looks like when the ventricles start to contract, that the ventricles build pressure, and they build pressure to the point that it meets the blood vessel pressure. When ventricular pressure is equal to blood vessel pressure, and then you see how this is the point where ventricular pressure exceeds blood vessel pressure, that's when the semilunar valves will open. The ventricle is going to eject blood into the blood vessel for this whole time. Makes sense because it looks like the blood vessel's taking on that same high pressure of the ventricle. But now look what happens when the ventricle starts to relax, when it starts to go into diastole, ventricular pressure right at this point, it drops below blood vessel pressure. And when ventricular pressure drops below blood vessel pressure, we know that's the point that the semilunar valve is going to close. And when the semilunar valve closes, look at that little transient increase in blood vessel pressure. That's because the blood now is going to crash against that closed door of the semilunar valve. That's known as a dicrotic notch. But the blood is going to move forward in the blood vessels, and so that that pressure stays higher, but it's decreasing over time. Ventricular pressure is really decreasing here. Now let's take a look at ventricular pressure and atrial pressure, the relationship between those two. So I can see ventricular pressure is lower than atrial pressure, but do you see how when the ventricles start to contract, right at this point, it looks like ventricular pressure exceeds atrial pressure. And when ventricular pressure exceeds atrial pressure, that's when the AV valves will close. So hopefully you notice a trend here. When there's a reversal of pressures, this seems to be opening and closing the valves. So ventricular pressure is lower, but when the ventricles start to contract, ventricular pressure exceeds atrial pressure right at that point. That's going to force the AV valves to close. Ventricular pressure builds when ventricular pressure equals blood vessel pressure. Semilunar valves open, right? And the ventricular pressure exceeds blood vessel pressure. Blood is ejected into the blood vessels. As soon as the ventricles start to relax, when ventricular pressure falls below blood vessel pressure, at that point the semilunar valves will close. Ventricular pressure continues to drop, and look at what happens here. As ventricular pressure drops, it's going to drop below atrial pressure. Now when we look at atrial pressure, what's happening during ventricular systole? It's slowly increasing, and it's slowly increasing because blood continues to enter the atria. So it's slowly increasing as blood enters the atria. When the ventricles relax enough, right at this point where there's a reversal, so that the ventricular pressure drops below atrial pressure, that's going to force the AV valves to open. And when the AV valves open, take a look at what happens in the atrial pressure, the one I highlighted in pink. Do you see how atrial pressure starts to go down? That's because all the blood that was collecting there in the atria will now just passively fall into the ventricles. So the AV valves are open, semilunar valves are closed. This is the start of whole heart diastole. Both chambers have a low pressure and blood's flowing directly into the ventricles.